Okay, so we now have a way that we're detecting through raycasts our ground, our ceiling, and our enemy here. Now, it's possible, and I've seen this before, where people will raycast like just a bunch all the way around, and so they can basically just detect everything. So you just send out a raycast, and it just shoots, and it just maybe frame by frame it does one at a time. So it's just this constant like moving around. But obviously, I'm not going to do that because that's just a lot of stuff. You probably make some sort of loop for it and make it work, but we're going to not do that. What we're going to do instead right now is do our jump. So currently, the way the jump is being handled is that it's physics-based. So if we go up to the top here, you'll see we have if, this should really be on a separate line, if input that get access is jump, so if we hit the space bar, that's what it's connected to in the inputs, and we're on the ground, it's going to add a force in the upward direction times our jump strength, right? So that's how it works. What I want to do is do this a little bit differently. Instead, what we're going to do is do a lerp, okay? And lerp just stands for linear interpolation. It just means it's going to blend from one value to another value, and we're going to do that over time. So basically, the idea is that in the game, we're going to say, okay, the first value, if my guy's on the ground, I'll just put him on the ground so you can see. If my guy's on the ground, okay, I'm going to say, okay, first value is the current position, and then I'm going to hit jump, and I'm going to say, okay, my end value is here. And then all I'm going to do is through code is say, I want you to blend from here to here. And it's going to go like this. And then we're going to release that and then just let physics take over for our person to drop from the ground. Okay, so they fall. I'm not going to do a fall one. The reason being is that jumping is always this height, unless it gets blocked like here, right? This would hit me. That's why we have the ceiling check, is to tell it to stop jumping if we hit something. But when we fall, we can fall farther down, right? Because I can fall all the way down here. So we're just going to let physics do that. And it makes it a little, I'm going to put them over here. It makes it a little bit easier, both for coding and also for playing the game, because usually people are used to doing that. Okay, so that's what we need to do, right? That's the idea. Now, so what we're going to do is that instead of what we currently have here, this add force, I'm going to go ahead and comment it out by just doing forward slashes. That way it's still there. If we, for some reason, want to go back to it, we can. What we're going to do instead is run a function, okay? So our function is going to be a coroutine, okay? And so just so you understand why we're doing it, I know it's a lot of confusing stuff, but so we want it to jump, and I want it to blend, right, from here to here. Well, that's going to take multiple frames, right? It's going to take multiple cycles for me to get from here to here, right? So it's going to have to go here on frame 1, then here on frame 2, then here on frame 3, and here on frame 4, and so on and so forth, right? The problem is that when you run code reads linearly, which means that when this update runs, right, update runs in every rendered frame, it cannot progress to this next section until this line is done. So what I mean by is that it has to run this line, then it will run this section, then it will run this section, then it'll run this section, so on and so forth. However, it will not be able to run this until this is over. So what that means is that if I tell my player to jump, right, what's going to happen is he's literally, the whole game's going to basically stop. Like, none of the rest of that is going to be able, I'd not be able to move left or right. It's just, everything's going to stop, and it's just going to go like this, and then the rest can run. But in this case, it particularly is a problem, because if I put it on update, right, that's every rendered frame. So that means the rest of the game is all dependent on him moving up, and the rest of it also has to stop. So you can kind of see where that becomes a problem, hopefully, because it can't go to the next line until this is complete. It can't run the next update cycle until this part is done. So what we're going to do is we're going to run a coroutine. What a coroutine does is that it allows it to run while the rest of it is running, which means it will basically, it'll run it once. What we're going to do, we're going to have a function down here. It's going to run the function once. And then when that function gets complete, it's going to send back and say, okay, go ahead and go to the next line. It's going to go to the next line, and when it comes back around, it will run the next part of that function. So basically, instead of it going over to this function doing all the stuff that it needs to do, and then coming back, what it'll do is it'll go over to this function. This function will run once, then send back. This will go ahead, then it'll send back to the function, then the function will, it'll go back and forth. Instead of this one hogging the ball, it will send back the ball, and so they can go back and forth. Okay, so they can run kind of basically simultaneously. It's not multi-threading. It's not running them really literally like two things at once. But what it is doing is it's allowing them to run sort of simultaneously. It'll run back and forth. Okay, that's the idea behind it. Anyway, so we're going to run a coroutine in order to do this. So it's a little bit different than your typical thing. You have to write start coroutine, and then you tell the coroutine you want it to start. In this case, it's going to be our jump lerp is the name of the function we're going to make, okay? And then semicolon, like that. So it's going to start jump lerp as a coroutine. Now, we need to make our jump lerp. And let's just go ahead and put this, I mean, it doesn't really matter where it goes. We'll just put after player animations, all right? All right. So we're going to do I enumerator jump lerp like this. So again, you can see it's not a void, right? And it's not a bool, because what this needs to do is it needs to be able to mark its journey, right? So an enumerator means that there are steps in it. So this allows us to basically keep track. All right. Okay. Okay. So now we're going to need to run our function here, our thing here that's going to do our jumping. This is kind of complicated, so just bear with me. I'm going to try and do the best I can. So one thing we're going to need to do is we need two things right off the bat when we first hit jump. One is we need our start position. So I'm just going to make a variable called player start y position, and I'm going to set it equal to the current player transform dot position dot y semicolon. And this should just be transform. I don't know why I did transform. Transform dot position dot y. So literally we're going to store our current y position into this. Notice that I didn't declare it here, so we could just do a float player start position. Okay. Then we need to do we need that, and then we also need this. So because we need to have, remember I said like we're going to say, hey, we're going to start at this position, and then I'm going to say what I want my end position to be. So I need to store where the start position is and where the end position is so that we can lerp, we can blend between those two values, okay? The other thing I'm going to need is our position. So what that means is that in our journey, this is position 0, and this would be position 100%. So then we would have to say, okay, we're at 0, you're going to be here, and then at 10% here, at 20, 50%, 75%, 100%. So we need to keep track of where we are on that path so that we know the number we need to give it, right? So like, let's say I'm going from here, and let's say this is equal to 5. This is a jump of 5, right? Well, I'm going to say, oh, you are now at 50%. Well, I'm like, okay, so if it's 50%, I need to give it a value of 50% of 5, that'd be 2.5. So put it at 2.5. So we need to keep track of where we are in the whole thing, okay? So that's our jump journey. Okay, so that's the other thing I need to keep track of is a float jump journey, and we'll give that a value of 0f. Okay, good. Okay, so that's the first thing we need to do is just store those two things so that we have it. Okay, now what we're going to do is this really shouldn't. I have it testing ground up here. I don't know why I put ground on there. I'm going to skip that. So then what we're going to do is we're going to say while basically our jump journey, well, we're on our jump journey still, and it's less than or equal to the jump duration, and we're not hitting a ceiling. Okay. So while our jump journey is less than our jump duration. All right, so jump duration, that's not a variable we have. So the way that we're going to define this, let's go up here. We need to tell our this lerp, right? It's going to need two values. It's going to need like we know where our starting position is. It's going to need how high do we want to jump? What's our ending position, right? So I need my jump to be to 3. So it'll take our starting position and add 3 to it. Okay. So I need to have that. So that's the we'll say jump length or the height of it. The other thing I need is how long should it take, right? Like I say, oh, blend up to here, but it's going to have to take some time. So that's our jump duration. So, oh, I want it to take 1 second to get up here. I want to take 3 seconds to get up here. So that's the other factor that I need. So we need to add a couple variables up here that's going to allow us to basically control that. So we'll go ahead and we're going to do a public float. This is just like we have our player speed and player jump strength. This is how we're going to control our stuff here. So we'll do jump duration. All right, and we'll just leave it like that for now. And then we're also going to need our jump height. Public float jump height. Okay, great. All right, let's go back down here. All right, so yeah, so when the jump, as long as the jump journey, which starts at 0, as long as while we're in it, we're less than the duration, it will keep this loop will keep running. Once we reach the end of our jumping, right? Once this number is the same as the duration, then this loop will break. Okay. Or if we hit the ceiling, that's why we did ceiling check. So we only want to keep going up, but if we hit the ceiling, you should stop going up. All right. All right. So now we're going to do is do jump journey is going to be equal to well, we could just do this. Well, it's equal to jump journey plus time dot delta time. All right. So we could just instead do jump journey is plus equal to time dot delta time. And that just means that take whatever you currently are, and then I just want you, time is just it's one of the objects inside of Unity, right? So time is time. And then it gives us the actual time. So basically, jump journey is we're just gonna add whatever the current time is on top of our jump journey time, which started out at 0. So we're just gonna add how much time has elapsed. We need to get it. Okay. Now what we're gonna do is make a new float %, and that is gonna be equal to math f dot clamp 01, and we're going to clamp the jump journey divided by, put a space there just in case, the jump duration. So basically we're going to find the percentage of how far along we are in our jump journey. Because remember, so let's say that our jump duration is, let's say it's 3 seconds, right? So when we first start off, our jump journey is 0. So we're definitely less than it. What I'm going to do is say, okay, we hit jump. How much time are we going to add time to our jump journey? We're going to see how much time has passed, right? So it'll add like 0.2 seconds or something. Then down here, we're going to say, okay, what percentage of jump journey are we in of the full jump duration, right? So just look at this as like a fraction, right? So we are this much over this because our total is going to be jump duration. It's going to take 3 seconds. But how far along are we in it? That's all this is doing. We're just loading it in as a percentage. That's all that is. Okay. Then, we are going to add another thing here, float curve percent, and that's going to be equal to this thing. We need to add another variable. So go to the top, and it's going to be here. So it's going to be a public, this is a weird one, animation curve jump anim curve. All right, so basically what we're going to do is that if I don't use this, the thing we're about to use, what will happen is that we are going to literally lerp, linearly interpolate, which means that when I hit jump, my player will move the same amount on every frame. So I'll get this very, very even, flat motion that's just going from here, the same rate all the way up till it hits the ceiling, and then it will drop. That actually will look much worse than what we already have, because it should go very fast, like it pops up, and then it slows down, and then it falls, right? Like if you throw a ball up, it starts out at max speed, and then gravity pulls it until it becomes no speed, and then it starts to pick up speed as it comes back down again. That's currently what's going to happen. So what we're going to do is that we're actually going to create an animation curve, and you'll see it later on when we make our variables. And what that animation curve is going to do is that we can then draw a curve of how it should progress. So we'll tell it to move faster and then slower, because it will basically multiply times that curve there. Okay, where are we at here? All right, so we're going to find the curve percentage of where we're at. So it's going to be the jump anim curve dot evaluate percent. So what we're going to do is we're going to say, okay, find the percentage of our journey that we are in. And then in this curve, imagine, if you can look at my cursor, imagine my curve's like this, okay? So let's say that according to this percentage, we're at 25%. So what it's going to do is it's going to look through this curve and say, okay, where is 25% of this curve? And it's like, it's right here. So that's the position that it's going to put it in. It's going to be based off of that position, the percentage position of this curve. So I'm going to do this just to make things a little bit easier so you can see what I'm talking about. So I'm just going to comment off this for a second and then save it. I have to comment it out because otherwise when we go to save it, it's going to freak out and not work. Well, maybe it'll still work. Let's see. Nope. Okay. Yeah, correct. Needs this. Okay. Sorry, I know this video is going to be a bit long, so I'm trying to explain it as much as I can. I'm not entirely expecting you to... Oh, I spelled it wrong. Man, I'm doing a great job with this. Oops. Got an extra enumerator. Sorry about that. All right, let's go back. Player controller script dot jump lerp. Not old code paths. Oh. We need to return null, and we're gonna do a yield return null. I think that should do it. Just to show you the stupid curve here. Okay, so just so I can show you. So basically, we now have this curve that we can put our own thing in. So we're going to use this one. Well, all we're saying is that you see it goes from 0 to 1. So when we have that percentage of our journey that we say, oh, we're, like let's say it's going to take 3 seconds. You imagine there's 3 seconds here, and then our jump journey starts here. And then as we add time, we're going to get up to 3 seconds. Well, it's going to find the percentage of what we have there. Okay. So let's say we're at 10%. Then it's going to say, okay, 10%, our player's Y position should be here. And then if it's like 50%, 50% is here, and then 100% is here. And that's basically what we're doing with that little bit of code here. Okay. And then let me just delete all that out. And this. Okay, good. All right. That's what we're looking to do. Anyway. Okay, so that's good. Now we got to do is actually make that our jump Y position. So we're going to do a float jump Y POS plus, I'm sorry, jump Y position is, where are we at? Jump Y position is going to be equal to math f dot lerp, and then a whole bunch of stuff. So we want to find what we're actually going to punch in. I need to get a number of what we're seeing here, right? So I have this curve percent, and that's this. But now I actually need to put that in there. So what that's going to be is going to be the player. This is the actual lerping. Start Y position. So that is, oops, this has got to be a capital P. Okay. So we're going to lerp between this number, and then it's going to be player start Y POS. I keep doing lowercase. I think because it's POS plus the jump height. Okay. Right, jump height. And then curve percent. Okay. So again, lerp is a method that's inside of the mathf class. And what that allows us to do is it's going to blend from our start Y position. Remember, that was the first thing we did is we just said, okay, where are we when we first hit spacebar? Then we're going to say, where do we want to jump to? Well, it's going to be where we started plus the jump height, right? So if I'm at a level of 10, like let's say it's 10 things in the air, and my jump is 3, well, then it's going to be that 10 plus 3. So I want to go to 13. And then we want to do that by this increment that we found by using the curve and our percentage of where we are in the jump. That's the idea. Hopefully that makes some sense. Okay. Good. Okay. So now we want to actually do the motion. So what we're going to do is do transform dot where are you? Transform dot position. We want to actually set the position, and we'll set it equal to a new vector 2, and it's going to need an x and a y as per usual. So our x will just be the same thing it ever was. So it'll just be transform dot position dot x, and then our y is going to be that number that we just had there, which is just jump. It's this number that we just found. Jump Y POS. Okay? So that'll do the movement. Now, the next thing I'm going to do is do this. We're going to do yield return null. So what that means when you see the yield return null is that basically it's saying send back the buck to my guy here and don't return anything. Basically allows me to pause this function. This will run once and it says, okay, send it back, but I need you to come back to me after. So this is going to send it back, and then it's going to send it here. All right? And we'll save that, and we'll see if it has a heart attack. It probably will. Ceiling does not exist in the current context. Ceiling. Okay. And it says line 109. I think, is it IE? Yeah, I just spelled it. I don't know which way is the right way. Where are you? I think this is wrong. I think the other way is right. We're going to roll with it, though. Yeah, it's totally wrong. It's bugging me. It's got to, oops, not this. It's got to be this. So I just got to switch it in these other ones. Where's the ceiling check? Ceiling. I before E, except after C. Right? Isn't that what it is? Something like that? So ceiling. then we're going to go up here. Sorry. You can leave yours if you want. Just make sure you switch that other one around. I feel like that's spelled wrong. I might be spelling them all wrong. Now it looks wrong to me. I don't know. God bless it. There. Save that. Doing a lot of misspellings here. Really failing. All right, good. So before this actually will work, it's just like before where I need to go to my player and I need to, where's the player controller? Okay, I need to put the jump duration. So let's say it's going to take, let's say 2 seconds. That's actually going to be longer than we need. And let's just do 5. That's actually going to be taller than we need. And then I want you to click on this and just choose this curve, this one right here to start with. And that should work. Let's just see what we have. This might break. I'm expecting it not to. All right. So it's definitely more than what we need. Let's go ahead and do, so jump duration should be like, let's try 1, and the jump height should be like 2. Let's try that. Definitely feels really long now. Okay. So that is fine. I'm also going to go to here and do linear drag. Let's try 2. Okay. So let's take jump duration and jump duration. Let's do 0.5. See what we get with that. You know, actually, it's kind of hard to tell because all that stuff's in the way. So let's do this view. Come on. Okay. So what this allows us to do, though, so notice also how consistent it is now. Because we're lerping our jumps and not our other stuff. But what this allows us to do is this. Like if I take this curve, I can, if you want it to be more like robust, I can right click on this and I'm just going to do right tangent because we're going to the right on this one. And I could do weighted. Gives me this little handle here. There's a handle anyway, but if you have it weighted, you can pull it like this. So watch this. I go like this. Oops, let's go really high. Now watch when we hit jump, he's going to pop. See how much he pops up now? And then he goes to the top. So we can actually totally change our jump depending on this. Like watch if I make it linear. It's going to be very mechanical. This is what it would look like actually if we didn't have that curve initially. See how it's just goes one consistent speed the whole time, which isn't really what we want. So we want more or less this, or actually we could try this one. Watch this. This is going to be bad. So it should start out slow and then speed up. See how it starts slow and then it gets faster? So that's the nicety of having this curve thing because basically it allows us just to have more control over it. And then you're going to want to probably play around with some of these numbers, like the linear. The linear. What is it called? Where are you at? The linear drag or something? Yeah, linear drag. 2 might be too high, might be too little. You can play around with these physics numbers. Basically, it's just dealing with the weight of moving down because you probably noticed that. Obviously, it was coming down really kind of fast. But this gives a little more time falling down. but it pops up a bit better than it did before, and that's what we were going for. All right. Now I want to just clean up a couple things real quick on the code here, just because of this. You'll notice that when we're doing our thing here, see how we declare this and then we do them? We're making a new variable every single time. It actually makes sense that instead of doing this, to put them up there and then just rename them constantly. Otherwise, what you're doing is you're creating and destroying variables every time. I know it sounds stupid, but you're better off not doing that. So, for instance, like these two, I'm going to go ahead and grab these, Control C, and go up here, and then I'll just do it after this bit here, Control V, and I'm just going to delete the values like so. Okay. Like that, right? So that we declare them up here, so we don't declare them every time we jump. And then I'm just going to remove this part of it. So they're not being declared, they're just being used. And I'm going to do the same thing with these here. Because otherwise you're creating and destroying variables constantly, and that's not very efficient. Okay, and then we'll just, again, take all these, delete, semicolon, take all these, delete, semicolon, take all of these, delete, semicolon, and then down here, I'm just going to go ahead and remove the variable part of it, of each one of these. Okay, and so, and then we'll just save that, and that's just much cleaner than declaring them every time. Okay, yeah, so I think, and I'll just leave that there in case you decide you want to use that instead, but I just want to cover how to do lerping. There'll be some other opportunities to use them later on. All right.